Hi everyone, my name is Ong Razor, my teammate is Yong Kiat, and today we're gonna present the assignment for fundamental of computer networks. First, we have our scenario for this assignment. The scenario is media wave broadcaster recently hired us as their network engineer to design their networks. It is a local area network with the number of hosts shown on the table below. It has three location A, B, and C. And then the scenario also require us to add up a 55% for future growth for every area. So this is our location design. Location A got we have three floor. Ground floor is production department. First floor is news room department. Second floor is administration department. For location B, ground floor we have engineering department. First floor is marketing department, and the second floor is human resource department. For location C, we only have a international news department. So next, we do the host growth table that with content of 55% growth. First, we need to use the usable host required from the scenario, add up a 55% of growth, then finally we get the final host number. Next, once we get the final host number, we use the maximum final host number to calculate all the network address. So we use 620 as our number of needed usable hosts. So for the subnet we need is 8, which is 7 department with one router to router connection. So in the scenario, it is given that the address is 10.0.0.0, which is a class A address with a default subnet mask 255.0.0.0. So after calculate everything, the custom subnet mask will be in decimal form 255.252.0 with a prefix /22. So we change it to binary format, and then it has 14 bits of subnets that has been borrowed from the host, and then it is 16K of total subnets, and then for the host address we have 1024, which is 10 bits of host address. So we need to subtract by 2 for the total number of hosts, because one is the network address and one is the broadcast address. So by using the binary format, we get the last ending one as our magic number, which is 4, because it is 2 power of 2. So by using the magic number, we get the addressing table. We're using the magic number to add in the third octet to calculate the network address from 10.0.0.0 into 10.0.4.0, and then we do it until the last department. Then for the first usable address, we use the network address, just the next of the network address to assign as our first usable address, which is 10.0.0.0.1 as our first usable address. And the last usable address is just before the podcast address, which is 10.0.0.3.254. For the broadcast address is the last of the range of the network's address, which is 10.0.3.255. So for the range of address is 10.0.0.0 until 10.0.3.255. But for usable IP is the first usable until the last usable only, which is 10.0.0.1 until 10.0.3.254. And we calculate all this until the last department. So next, we introduce our topology design. This is our topology. Each department has 3 PC that connect to a switch as our simulation. So each of the switch is connected to a router, and we have two router connection between location A to location B. The reason why we using two router is because we need to distribute the workload to two routers so that it will decrease the latency and prevent the package loss. And we are using the fiber optic cable to connect the router to router because from location A to B is 500 meters distance, and for copper wire it only can support until 100 meters. So 500 meters is already exceeds 100 meters, so we need to change to a better cable which is fiber optic. Fiber optic can support until 10 kilometers, and it has a better bandwidth because due to it is a good transport traffic. And we also using fiber optic to connect to the switch at the location C. So for location C, we using the copper crossover cable to connect switch to switch due to the reason it is using the same device. Same device we need to use copper crossover. For the different device we need to use copper strip 2 cable to connect it. Now I need to pass my section to my next teammate, which is Yong Kiat. Thank you very much.
Thank you, Riza, for passing the topic to me. Hello guys, I'm Kiat. So today I'm going to show the network configuration for this network topology. So first of all, let's start to look at the router R1 configurations. In the router R1, we have set the password of CLA33 onto the line console 0 and also the every VTY line, which is from line 0 to line 15. The reason that why we see the password is not shown here is because that we have enabled the password encryption service. So next, you have also set the enable secret, which is the AACS2034. Next, let's look into the interface part. The interface we choose to connect to the each switches is the Giga Ethernet interface. The reason that why we choose Giga Ethernet compared to the fast Ethernet is because the Giga Ethernet can support a higher bandwidth compared to the fast Ethernet. So next, we have also set the static routing to this router. The reason that why we have to set this static routing in this network topology is because we're having two routers in this network topology. Without static routing, these two connections in each router can't communicate with each other. Next, let's proceed to the ping test. We'll ping this AD1 PC to the AD3 PC which having the IP address 10.0.0.5. It can successfully be pinged. So next, let's ping to another PCs in different department that connected to the same router. So now I'm going to ping the PCs in newsroom department, which is the ND1 that having the IP address of 10.0.4.3. So now it is successfully be pinged. Now we are going to ping the host at location B. So let's choose on the human resources department, which is HR1 that having the IP address of 10.0.16.3. There's no issue on the connections. So now we have to test to ping to the switch that having the IP address of 10.0.0.2. It is successfully be pinged, so which means that the connection in it have no issues on it. Next, let's try to ping the host in department at location C, which is the international news department. So let's try to ping the IND1-1 PC that having the IP address of 10.0.28.4. As we can see the result, it is successfully been pinged. Next, let's ping the router to the router to ensure that the connection between the routers is established and connected successfully without any issue. Now, we are going to try to ping from the R1 router to the R2 router that having the IP address of 10.0.12.2. As we can see the result, the pinging request from R1 to R2 is successfully be returned. So which means that the connection between them is successfully connected without any issues. So that's the end of the presentation from us. Thank you very much for watching this video.